Greetings Advisory Board. My name is Robin Harrison. I currently attend Clark Atlanta University as a sophomore biology student. Today I'll be explaining the concept of negative versus positive transcription regulation. Here we have two DNA strands. So for the first one, we're going to be showing an example of negative transcription regulation. So first, I'm going to explain promoter region and the operator region. These two regions are very important because in order for DNA to be transcribed, we need the RNA polymerase to be able to bind to the promoter region. And the operator region is important because this region is where our repressor protein or activator protein is going to bind so that we can know if we're going to be able to transcribe RNA polymerase or not. For negative transcription regulation, we have the repressor protein. For our positive transcription regulation, it's going to be the same exact diagram, but the difference will be the activator is now involved. So for the RNA polymerase, in order for it to be able to transcribe the DNA strand, we need the repressor protein to not bind to the operator site. So in order for the repressor protein to not bind to the operator site, we need the activator protein to bind to the repressor protein to change its shape so that it can no longer fit onto the operator site. So now, if we have our activator protein involved, then we have a positive transcription regulation. But if the activator is not involved, then we have a negative transcription regulation, and then the repressor protein will bind to the operator, and then the RNA polymerase will not be able to move down the DNA strand. When we have a negative transcription regulation, that's used in every single gene, depending if we want the gene to be able to express itself or not. When we have positive transcription regulation, that means that the gene will be able to express itself. That will be the end of my presentation. Thank you for the consideration. Goodbye.